Heading to today's angle modulation. We have discussed it already. Please write down, I hope notebooks are on the mark. So, in angle modulation, angle of the carrier angle of the carrier will be varied in accordance with message signal variations. In angle modulation, the angle of the carrier. In angle modulation, the angle of the carrier will be varied in accordance with message signal variations. It has two types. It has two types. It has two types. Point number one, A. If angle modulation occurs due to dependence of Fc, if angle modulation occurs due to dependence of Fc. What is Fc? Due to dependence of Fc. What is Fc? Right. Due to dependence of Fc on m of t. If angle modulation occurs due to dependence of Fc on m of t, then it is called as frequency modulation, that is Fm. So, if the angle modulation occurs due to the dependence of the carrier frequency on your m of t, it is called as frequency modulation. However, in second case, if angle modulation occurs due to dependence of phi. Yeah, this is type number 2. Eyes on board is important. A type and B type. So in second case, if the angle modulation occurs due to dependence of phi, Sara same hai. Dependence of phi. What is phi? Phi is the phase angle on m of t, then it is called as phase modulation. कुल मिला के दो टाइप ऑफ मॉड्यूलेशन है. एंगल मॉड्यूलेशन की जो टाइप्स है वो दो है. आइज ऑन बोर्ड प्लीज. एंगल मॉड्यूलेशन टाइप्स वी हैव टू. One is frequency modulation, another is phase modulation. But we will not go into the details of phase modulation. We will directly go to the frequency modulation. Is that okay? Because that is what our syllabus tells us to do as of now. Those who want to see phase, they can come to me. We can see that also. But just to manage time, because in your exam which is coming up, we will have 2 units for your exam. One is that we have done, and another is this one which we are going through right now. And this one we will obviously go at a very higher pace. So I want all of you in class and vigilant, because इस time ज़्यादा वक्त नहीं है कि मैं ज़्यादा दाएं बाएं जाऊँ. So whatever is taught in class is precise and is obviously everything is important for class, because I am saving some time. Okay. So make sure to attend your classes regularly and on time. Anyways, So heading लिखिए frequency modulation. So let's assume that frequency of carrier. Then let's assume that the carrier C of t is equal to AC cos of 2 pi fct. Now these are not new things, we know what they are. Therefore, frequency of carrier before modulation is equal to fc. है ना? मैंने क्या कहा? फ्रीक्वेंसी मॉड्यूलेशन में जो इम्पैक्ट आएगा वो किस पे आएगा? कैरियर फ्रीक्वेंसी पे. So that's why I am analyzing the carrier frequency. So carrier frequency before modulation is fc and frequency of carrier after modulation will be given by a value called as fi. When fi is, आप यहाँ पहुँच गए? fi लिखा आपने? fi लिखा? Okay. When fi is called as instantaneous frequency. Where fi is called as instantaneous frequency. Where fi is called as instantaneous frequency. And is given as eyes on board. I will not be loud today. I will be very low. Fi is the instantaneous frequency. Fc is the carrier frequency. Ef is frequency sensitivity of frequency modulator. Kf is frequency sensitivity of frequency modulator. Therefore, in this expression, eyes on board please. In this expression, I have Fi is equal to Fc plus Kf m of t. Case 1, case 1, if m of t equal to 0, ये सारा वाला part 0 हो जाएगा. Fi is equal to Fc. If m of t equal to 0, क्या बात है? ये वीडियोस हम किससे रिकॉर्ड कर रहे हैं, इसीलिए जो आप मिस आउट कर रहे हैं वो बाद में करें या बाद में क्लास के बाद करें. लेकिन आई स्ट्रांगली से कोई किससे पूछेगा नहीं, या तो मुझसे सुनो, मिस हो गया यहाँ से देखो, या बाद क्लास के बाद में ड्यूरिंग क्लास मत डिस्टर्ब करो. केस 1 m of t इक्वल टू 0. आप बताइए खुद से, शाबाश. m of t 0 है, fi will be equal to fc. डन. केस 2 m of t is पॉजिटिव. केस 2 m of t is पॉजिटिव, मतलब एक बड़ा वैल्यू होगा m of t का. सो fi और fc में क्या रिलेशन होगा? fi will be greater than fc. fi लेफ्ट साइड से, लेफ्ट साइड ऑफ द. सो केस 2 when m of t is positive, इस टाइप का ये बैलेंस इक्वेशन. लेकिन जब हमने m of t को बढ़ाया, मतलब ये वाला पार्ट इंक्रीज हो गया, तो ऑब्वियसली fi भी इंक्रीज हो जाएगा, राइट? केस 3 क्या बनेगा, जरा खुद से सोचो. m of t is negative, fi is less than fc. क्या होगा? केस 3 ये कम हो गया, m of t नीचे जा रहा है, इमेजिन दैट साइन वेव का पॉजिटिव पीक एंड साइन वेव का नेगेटिव पीक। तो जब हमारे साइन वेव का, मैं किस साइन वेव की बात कर रहा हूँ आप बताइए, इसको बुलाओ, मैं किस साइन वेव की बात कर रहा हूँ, आ जाओ आगे, आ जाओ। क्यों करा है ध्यान, क्या करा है, चलाया बस। ये जो आपने ये एनालिसिस की, मैं बात कर रहा हूँ अपनी मैसेज सिग्नल की, एम और पी। मैंने आपको ये बताया जब ये 0 पे है तब एफ आई और एफ सी सेम होंगे, लेकिन जब आपका सेम पॉजिटिव पीक है, आप पीक मैक्सिमम वैल्यू की बात करें, तो आपका एफ आई जो है फ्रीक्वेंसी का वैल्यू क्या होगा, ज़्यादा होगा। जब एम ऑफ टी मैंने नेगेटिव कहा तीसरा केस, यहाँ पे एम ऑफ टी जब कम हो गया तो एफ आई भी कम हो गया, ये याद रखना। ओके, नेक्स्ट पॉइंट, इन फ्रीक्वेंसी मॉड्यूलेशन, in frequency modulation the voltage variations, in frequency modulation the voltage variations of message signal are converted as, the voltage variations of message signal are converted as corresponding carrier signal frequency variations. The voltage variations of message signals are converted as corresponding carrier signal frequency variations. मतलब हम एक हिसाब से देखें ये वोल्टेज टू फ्रीक्वेंसी कन्वर्शन हो रहा है, हाई वोल्टेज हाई फ्रीक्वेंसी, लो वोल्टेज लो फ्रीक्वेंसी। Isn't that clear? सिंपल है ना? So it is also called as voltage to frequency conversion. Zuba, oh Zuba, sabuche tarah. Do you get my point? So it is basically a voltage to frequency conversion. When we have high voltage of f of t, we have high frequency. Fi will be high. Simple, based on the equation. When f of t will decrease, Fi will also decrease. This is what you need to understand. Voltage to frequency conversion. Voltage to frequency conversion. So I can write the same thing as Fi is equal to Fc plus delta F rather I will write F max. Now देखो, imagine your m of t be equal to am cos of 2 by fc. Okay, now this is your, although for cos I might start from here, but that's okay. For sine and cosine this is okay for case. You can take it as or am sine of 2 by xt also, as you like. What is important for me is not the point of starting of the signal. What is important is the peak. At this peak and at this peak, the value over here will be am and here it will be minus am. Okay? Am will generate f max, right? Am I right? Because at that point of time, the value of frequency will be higher. And minus AM will generate Fmin. Okay? Or else I can write F max will be equal to Fc plus KFAM, and F min will be equal to Fc minus KFAM. How? Because AM is positive, I have positive here. AM is negative, I have negative here. As simple as that, right? Is it logical? So I can say that maximum frequency deviation is equal to max of KFM of T. Because if you remember, इससे पहले मैंने क्या एक्सप्रेशन लिखा था? Fi is equal to Fc plus KFM of T. So F max can be derived. F max will depend on maximum of KFM of T, which is nothing but KFAM. So maximum value उसका AMT है. Therefore, frequency deviation is given by delta F. ये आप एक्सप्रेशन याद रखेंगे, बहुत इंपॉर्टेंट एक्सप्रेशन है आपका. Frequency deviation for an FM signal is equal to KFAM, and this one also. Therefore, F max ये फ्रीक्वेंसी Fi का वैल्यू, Fi क्या चाहिए? Fi है instantaneous value of the carrier frequency after modulation. बेसिस तो Fc रहता, जब ये 0 होगा, M of t जब 0 होगा तो Fi और Fc बराबर होगा. M of t का जब वैल्यू थोड़ा सा बढ़ेगा, Fi का वैल्यू थोड़ा सा बढ़ेगा. अब हमने लिया इस M of t का मैक्सिमम वैल्यू. M of t का मैक्सिमम वैल्यू क्या है? वो है ना AM. So that's why F max will be Fc plus KFAM, which is there. Obviously, then F min will be generated by minus AM. इसके बाद देखिए next point, total frequency swing. Total frequency swing of FM सिग्नल. ये आप सिग्नल की बात हो रही है. एफएम जो हमारा सिग्नल है, उसकी टोटल फ्रीक्वेंसी स्विंग जो होती है, दैट इज इक्वल टू जो आपने यहाँ पे डिराइव किया एफ मैक्स माइनस एफ मिन. जरा मुझे बताइए किसके बराबर आता है? एफ मैक्स माइनस एफ मिन. टोटल फ्रीक्वेंसी स्विंग ऑफ एएम सिग्नल, सॉरी ऑफ एफएम सिग्नल इज एफ मैक्स माइनस एफ मिन. इसको पुट करो ना, KFAM को पुट करो पहले डेल्टा एफ. पुट KFAM इज इक्वल टू डेल्टा एफ. So you rightly are saying that it is equal to twice of KFAM, or I can write simply 2 times delta f, where delta f is what? Frequency deviation, and total swing of FM signal जो variation होगी total उसमें, that is twice of delta f. Is that okay? हाँ जी बोले. Is it done? Shall I clear this? आज क्लास खत्म होने से 10 मिनट पहले ही आप मुझे बोलेंगे क्लास खत्म हो गई. ठीक है, क्लास खत्म होने से 10 मिनट पहले ही आप मुझे याद दिलाएंगे that class has ended because I have to leave 5 minutes earlier. Now let's see the analysis. My M of t. So let's see the analysis part. Imagine my M of t is given as a signal such as this. Eyes on board please. एक सिमेट्रिकल साइन वेव हमने बनाई है and my this is not the time for discussion please, no discussions, and your carrier signal is given as something like this. Your FM signal will have the same amplitude as that of carrier. This is AC and this is minus AC, while this is AM and this is minus AM over here. Your modulated signal will have the same amplitude as that of AC. But the only difference that would be eyes on board एक मिनट के लिए ये वाला पीक है इसको आप एक्स्ट्रापोलेट करेंगे यहाँ पे, इस वाले पीक को भी एक्स्ट्रापोलेट करेंगे यहाँ पे एंड इस पॉइंट को भी. ऐसा क्यों किया हमने? बिकॉज as we start our frequency might be same but it will be very high over here. Slightly it will start going down and equal to the carrier frequency and frequency will be very less over here. It will start again to become maximum and will again start decreasing. So you can clearly see that this point over here is nothing but F max point. This point over here is nothing but F min point. And the same thing continues, right? So we have bands of frequency, high frequency bands and low frequency. Therefore, we get to know how the message signal has impacted the carrier frequency now. When I send this carrier frequency from a receiver to from a transmitter to a receiver, on the receiving side, when I have high frequency and low frequency, the place where I have the highest frequency, I will be able to understand this is the maximum peak of my message signal. And as I move on, when I have the lowest frequency, I will come to know that this is the lowest peak of the message signal. So I can decode my message signal back again from the frequency variations. This is all about FM modulation and demodulation in a way, just a simple way. Angle modulation में हम देख रहे हैं ये FM. This is a FM signal and we denote it as S of FM of T. Okay, this is your FM signal. न्यूमेरिकल लिखिए जरा. An unmodulated carrier frequency, is equal to 1 megahertz. Unmodulated carrier frequency is equal to 1 megahertz. I repeat, an unmodulated carrier frequency is equal to 1 megahertz, comma, after frequency modulation, maximum possible frequency is equal to 1.25 megahertz. After modulation, या frequency modulation actually, maximum possible frequency, actually F max, is equal to 1.25 megahertz. Question is find F min, comma delta. F min और delta F को आपको ढूंढना है. ढूंढे सर. You got my point, Jana? The question is very simple. You just look for the previous formulas and find the answer. This is the numerical which I have just assigned to you. You can look for G. Delta equal to Fi minus Fc. Fi जो है आपने वो Fi की बदले F max लिया. So in a way you will get del F max. Del F equal to 1.25 minus 1 Fc max लिया है. That carrier frequency before modulation. आपने कुछ ट्राई नहीं किया इसलिए आपको समझ नहीं आ रहा है. अगर आपको ट्राई करते तो फिर आप देखते. सबको समझ आ गया? Yes or no? Anyone saying no sir, say it loud and clear. Anyone? जिसको समझ नहीं आ रहा है नहीं समझा? question, for an FM signal, F max is given by, for an F, ये सबने किया? Anyone जिसने नहीं किया? आपने किया? Okay, next question. Next question, for an FM signal. Now listen to me please. For an FM signal, F max is given by 2 megahertz. For an FM signal, F max is equal to 2 megahertz. Total frequency swing is 800 kilohertz. Total frequency swing is equal to 800 kilohertz. Find delta F, FC and Fmin. Okay, just try it out. I want to see it. Solid. So the solution to this is, we first write those things which are given. F max is given, that is 2 megahertz. Then your twice delta F is equal to 800. So first thing, delta F is equal to 800 divided by 2, which is 400. मैंने कहा total frequency swing. Total is always equal to twice of delta F. So you got delta F. That is done. Now you need to find FC. For FC, you know FC is equal to F max minus delta F. Right? Because delta F is equal to, F max is equal to FC plus delta F. You keep FC from one side, delta F goes to other side and becomes minus. This is mathematics from 8th class. I don't need to do this. So the answer comes out to be F max is how much? 2 megahertz minus delta F, that is 400 kilohertz, or I would say 2 megahertz minus 0.4 megahertz, because 400 kilohertz is 0 megahertz converted to 0.4 megahertz. By the way, for your information, kilo is equal to 10 raised to power 3, mega is equal to 10 raised to power 6, and gigahertz will be equal to 9 and 10, 12. Pico and micro are in minus scale. This is giga is 12. Okay, we will correct it later on if it is wrong. Then next to the आपको whole class is actually looking to this matter because of you. When आप बातें कर रहे हो, so F min is then equal to FC minus delta F. Actually formula में ये use की, then you can find it, right? आप थोड़ा twist है कहानी में. What is the time? Okay, a sinusoidal carrier. देखिए जरा 2 मिनट. A sinusoidal carrier of 20 volts. I repeat, a sinusoidal carrier of 20 volts. Yeah, of maximum value equal to 20 volts. Comma, with frequency 2 megahertz. A sinusoidal carrier of 20 volts and frequency equal to 2 megahertz is frequency modulated is frequency modulated by a signal given as 10 sine of 8 pi into 10 raised to 3t. A carrier is frequency modulated by this signal, so this automatically becomes the message signal. Okay, any signal, any carrier signal modulated by any other signal, the other signal becomes the message signal. I have not written that, but you should understand that. With kf equal to 50 किलोहर्ट्ज पर वोल्ट. मैंने आपको लास्ट टाइम कहा था एम्पलीट्यूड सेंसिटिविटी होता है कि पर वोल्ट कितना एम्पलीट्यूड में चेंज आएगा. इसी तरह फ्रीक्वेंसी सेंसिटिविटी होता है पर वोल्ट. आइज ऑन बोर्ड. I told you last time that amplitude sensitivity Ka, if you remember Ka for an amplitude modulator used to be amplitude, eyes on board, used to be amplitude sensitivity, and it actually identifies how much of amplitude change with respect to the amplitude variation, the voltage variation of the message signal. Likewise here Kf is a frequency sensitivity and it shows how much of the frequency changes per volt change of the message signal. Okay, fine. You have to find delta F, F min and F max. अब तो आप फंस गए, वो फॉर्मूला यूज नहीं कर सकते हो. डेल्टा F, F max and F min को ढूंढना है. ये आप ढूंढिए और आप मुझे मिलिए अगली क्लास में जहां हम फर्दर देखेंगे क्या करना है. So with that we will stop, but we will stop also there.